Welcome to my channel, viewers. And today this is the discussion about the chapter of quadratic for class 11 and some competitive exam who are want to apply the JEE IIT and advanced and also the Indian Statistical Institute. And some problem are important here. Now today I want to introduce 8 different type of problem here. Okay. Now, first we have to discuss this point, and that is the 44. And it is given that, and this is the this problem are taken from these 8 problem are taken from the book of I.S.C, and this is the second marks for sections. And we have follow the question number 44 is that, and this expression is a positive for all real values of x, and so that x has a no values between 5 and 7. Now we write this expression and see, and that is 44 of marks 4 here, x minus 5, and see x square minus twice x plus 1, and here is x minus 7, and also here x square plus twice x plus 3 here, and see this expression is a positive. Now see these two part clearly view is there is a positive. So this is x minus 5 by x minus 7 here, and now into doing here x minus 1 whole square, and also x plus, actually this is 1 whole square, and then I have addition 2 is this. So clear view is that this is positive and this is also positive. So we have to show this expression is positive, since so x minus 1 whole square is positive, and this is a clear view we get here. This is also a positive. Therefore x minus 1 whole square divided by x plus 1 whole square plus 2 is more than 0. Therefore we have to take x minus 5 by x minus 7 is more than 0, since the given expression is positive. Okay, this is our clear view. In the question says that this expression is positive. So as the expression this is positive, so we have take a positive sign. Okay, now from this x minus 5 by x minus 7, and this is here more than 0, and now this is the technique we have to use here. See, multiply by the numerator and denominator by x minus 7. So like that. Okay, this is the writing style. No need to be a technique here. This is a square, and this is a clear, this is a positive. So like that, 2 by 3 is more than 0, so you can write this is more than 0, but here 2 by minus 3 is less than 0, so if we transfer this is never be actually less than 2 here. So if you want to know, this is multiplied by minus 3 on the numerator and denominator part, then we get here minus 3 whole square. After that, we can say that if this expression has transferred to the right hand side when it is a positive, so then we can say that this is product is less than 0. Okay, so this is a technique. So that's why we have to multiply numerator and denominator part by x minus 7, where as we know in the numerator part we have x minus 7, and now clear view is this positive, so this is transferred to the right hand side. Then we get here x minus 5 and x minus 7. And that product is more than 0. Now we draw a number line here. See carefully. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5. This is a 5. This is a 5. And this is a 7 here. So now see which region would be satisfied for this case. If we take more than 0, and this is there under 2 and 5. If we apply the under 2 and 5, it means more than 5. So this is 5.y, this is a positive, but it is a negative. So the does not satisfy the more than 0, so we can take don't take the interval of 5 to 7 here. If we take less than 5, that is 4.9, it is negative and also negative, therefore product be positive, so it's satisfied. So therefore it is hold, therefore we can write here x is less than 5 and x is more than 7. Okay, so therefore x has no value between 5 and 7, therefore x has no value between 5 and 7. Okay, 5 and 7 have no values there. Okay, so this is the concept of question number 44. Now proceed the question number 46 here, and see carefully and copy this technique to solve these inequalities with them. Okay, and we have to show this is a positive when and the value of the expression don't lie between 5 to 7 here. Okay, so see the next question is 46 here. So 46 and same technique is there. This is a 46, and see we have a expression, this is x minus 2 and x minus 3 and x minus 4 and x minus 5 and plus 2 here, and see this is the expression is always positive, you have to show. And students, see the technique, the two and pair of the two factors we have to multiply to each other. Actually we want to get a two term be the same, so that's why if we added 2 or 3, this is the 5, but this is 4 and 5 is 9 here. If we added 2 or 4, that is 6, but this is the 8 here. So now 5 and 2, this is 7 here, and 3 or 4 is 7 here. So these two factors are multiplied to both of them, and then other is the factor is x minus 3 and multiply with the, okay, we have to take a minus 4 here, okay, plus 2 here, okay, this is, and if we multiply these two with that and also this, then what we get there, see, I get here x square, and this is there minus 7x. Actually we mean to say these two terms are same, or both the expression we have get here. This is here 5 to the 10 here, and now see again x square minus 7x and 3 to the 12, and this is 2 here. Okay, see these two are same. 7 5 to the 10. Say x square minus 7x and as a. So this is a plus 10. This is a plus 12 and multiply with them, and this is a square. 10 or 12, that is 22. A, that is 120 plus 2. And now look here, a square. 2 into a dot 11 plus 11 square. So here 1, 2, 2 minus 1, 2, 1. Actually this we added here, so this is balanced. So balancing for minus, minus. Okay, now a plus 11 whole square, and this is here 1. Now the value of expression of a is here x square minus 7x plus 11 whole square plus 1. So this is positive. So that it shows that the given expression is positive. Proved. Okay, see the solution here carefully. And now 44 and 46 are done. Okay, now proceed to the 31st. Okay, see, so that the roots of this equation are equal if either v equal to 0 or this. So first we write here the equation is bc x square and 2 into b square minus ca into x and c square minus ab equal to 0. As now let a is equal to actually a square minus bc, and b is equal to 2 times of b square minus ca, and c is equal to c square minus ab. Okay, now and now as the roots are equal, then b square minus 4ac equal to 0 here. AC. C means this is here 4 or 4 cancel. So now squaring both sides, this is b to 4 here. C square a square multiply with this, so a square c square minus plus a cube b minus plus b c cube minus plus minus a b square c is equal to 0. Now here these two terms are cancelled and take a common b, so b to the power q, write here a cube, and this is here c cube, and have a addition of the these two terms is thrice a b c. So therefore either b equal to 0 or a cube, b cube, and c cube minus thrice a b c. And see, this is your proof, but some of the other problem need to solve to factorize this. Okay, if we factor, then we get here a plus b plus c, and either a square plus b square plus c square minus ab minus bc minus ca is equal to 0. Okay, therefore either a plus b plus c is equal to 0, and or a square plus b square plus c square minus ab minus bc minus c equal to 0. Multiply by 2, then we get here 2a square and 2b square, 2c square, and twice ab, twice bc, and twice ca, and equal to 0. So we can write here a minus b whole square, b minus c whole square, and c minus a whole square equal to 0. So therefore we can write here a minus b equal to 0, and b minus c is equal to 0, and c minus a equal to 0. So you have to take a condition is that, okay, so equal to b equal to c, either this equal to 0 or this equal to the condition. Actually question is this, either b equal to 0 or this, and in place of this factor we have to need to solve and sometime of given this condition, either this equal to 0 and a equal to b equal to c actually. Okay, I think all of you better understood what we want to say here. Okay, now this is 31st and proceed to the 32 and see, and this is for the 32 here, and see in the first equation is a x square and px plus q and equal to 0. Okay, if the roots of this equation be imaginary, as roots are imaginary, so p square minus 4 q square is less than 0. So this is the number one case. Okay, and so that the roots of this equation are real. Now use equation 1, actually in equation we have to show of the roots of the equation, that is x square minus 4qx plus p square equal to 0 are real and unequal. Okay, now find the discriminant of 4qx plus p square equal to 0, and that is b square minus 4ac, and that is equal to b square minus 4ac ac. Okay, and c, take a common 4, then you get here 4q square minus p square, and see here p square is less than the 4q square, so you take a common minus, then what we get here, p square minus 4q square. Okay, and this is actually less than 0. Oh, sorry, this is actually given that this is expression is less than 0, so this is less than 0. Negative and negative, that product be positive here actually. Okay, so this is more than 0 since p square minus 4q square is less than 0. Okay, so it shows that the equation it shows that the roots of the equation x square minus 4qx plus p square equal to 0 are real and unequal. Okay, interesting question. See the solution carefully. Okay, now you have follow the question number 35. Here, and these two equations, that is x square plus px plus q equal to 0 and x square plus p dash x plus q dash equal to 0 have a common root. Okay, let alpha be the common root of the equation x square plus px plus q equal to 0 and x square plus p dash x plus q dash equal to 0. Therefore, alpha square p alpha plus q equal to 0. So alpha square plus p dash alpha plus q dash equal to 0. So now find alpha square, alpha by and 1 by. Okay, and you know the technique of solving the cross multiplication method to find how are the common root here. So how we are finding the common root here. So this is here alpha square and coefficient here is 1 dot and this and dot here is 1 and this is 1. Okay, if we take a alpha square, then sorry. So if you take a alpha square, so this is we're doing of this column. Okay, then after these two term are exist here, and we have to take a coefficient all of the alpha 1 and alpha 1, and this is coefficient here is p and q, and p dash and q then, and multiply by the cross multiplication method like that. Okay, p q dash, okay, p q dash minus, then as a zigzag method. Okay, and q p dash. Okay, if we take alpha from that, see the arrow are exist here, so the coefficient of this column here is 1, and don't multiply like this. This is multiplied by this exact method. This is here q into 1. Okay, and actually we have taken 1 here, so therefore we can say the coefficient of 1 is here q and coefficient 1 is a q dash. So multiply by with q1. Okay, q dot 1 minus 1 dot q dash. If we take 1 here as a variable, so now here again start from here, okay, so multiply the zigzag method, not like that, okay, only zigzag method. So 1 into p dash, so minus p into 1 dash. Okay, so see, if we take this equal to this, actually this equal to this, so alpha never be 0 there, so we can cancel alpha, and then alpha is equal to, and p q dash minus q p dash by q minus actually q dash here. Again, if we take from these two, then we get here alpha is equal to, if you multiply this here, q minus q dash by p dash minus p actually. Okay, I think all of you are better understood, and this is a very interesting question to solve 35. And now we have a solution of 36 here. See carefully, and we have to proceed the same technique here, and also this is we have to solve the 36 here, and I have a common root both of them, which is given here. See, this is 36 here. Let alpha be a common roots of x square plus px plus r equal to 0, and x square plus rx plus p equal to 0 here. Okay, now alpha square plus p alpha plus r equal to 0, and alpha square plus r into alpha plus p equal to 0. Just we have to subtract this here, which we get the solution easily. And see, and this is, we can write here 1, and this is here 2. Okay, and doing subtract this, we have a common alpha in between them, that is p minus r here, and also this is r minus p equal to 0. So then we get here p minus r, and actually minus taken common from that, then we get here 1 dot p minus r actually. So either p minus r equal to 0 or alpha minus 1 equal to 0. So either p equal to r or alpha equal to 1. When alpha equal to 1, then from 1 or 2 is 1 square p dot 1 plus r x equal to 0, that is p plus r plus 1 equal to 0. So either this equal to 0 or p equal to r. Okay, see 36 here. Okay, now for the question number 17. Now here is the 17. See, if p and q are the roots of this equation, okay, so that's why we can write 3x square plus 6x plus 2 is equal to 0. So p plus q, and that is equal to 6 by 3, that is minus 2, and p into q, that is 2 by 3 here. Okay, and so that the equation whose roots are, and find the equation whose roots are this. So we have to find the addition and product also. Now let us assume as a n, and that is minus p square by q, and n is equal to minus q square by p. Okay, right here q. Okay, so that is, now we have to find m plus n, and p square by q plus q square by p. This is your pq, p to the power 3 and q to the power 3. PQ, P plus Q whole square whole cube minus 3PQ, and this is P plus Q. The value here is minus 2. So this is a 2 by 3, 6 by 3. Okay. So minus 8, 3 into that is 2 by 3, and P plus Q here minus 2, and P into Q that is 2 by 3 here. Okay, see, these two are cancelled. So minus minus minus, actually this is minus, okay, minus 8, and this is minus minus plus, 2 to the 4, okay, into 3 by 2. This is here minus plus, so 4 into 3 by 2, and this is 6. Now m into n, that is a minus p square by q minus q square by p, so pq, and this value is 2/3. Therefore the equation is x square m plus nx and mn equal to 0 here. So x square, that is x square m plus n, m plus n, m plus n, that is 6 here, 6x plus m, this is 2 by 3, x is equal to 0. Actually I have a wrong, okay, minus, okay, and this is 2/3. Now take the LCM, then we get 3x square and 18x and 2, not x here, and equal to 0. So this is your solution. Okay. And now 18. Okay. If the sum of the roots of this quadratic equation and is 2, let alpha and beta are 2 roots. So therefore alpha plus beta is equal to 2, and sum of their cube, and that is alpha cube plus beta cube equal to 27. Okay, and we can write this is beta whole cube minus 3 alpha beta, and this is alpha plus beta, and this is 27 equal to 0 actually, and this is alpha plus beta. Okay, you have to find, okay, easily, actually this is easy to solve here. So you take 27 here, and this is 8, and this is 3 into this is 2, alpha into beta is equal to 27. So now 6 alpha beta, this is 2 and 3 is 6 alpha beta, that is 8 minus 27, and this is 19, I think this is 19 plus 8, that is I think 27. Okay, so this is alpha into beta is equal to minus 19 by 6 here. Therefore the required equation is x square alpha plus beta x and alpha beta equal to 0. So now see x square, and some of the roots are here 2x, and product of this here minus 19 by 6 here, and take a LCM with 6 here, 6x square, and 12x minus 19 equal to 0. Okay, see the solution carefully. And now next question is 23rd. You have to follow this question, and this is also a very interesting question. And see the solution. The ratio of the roots of this equation are in the ratio r is to 1. Okay, the ratio of the roots of this equation ax square plus bx plus c equal to 0 is r is to 1. Main proof that is this. Okay, and this is here 23rd. The ratio of the roots is r/1. Therefore, the roots are rk, k of the equation, and that is ax square bx plus c equal to 0. Therefore, rk plus k equal to minus b by a implies that k into r plus 1 equal to minus b by a. Okay, now rk into k, c by a, r k square actually, and this is c by a. Now from 1 and 2, find k and put here k. Rk, k means here, since k is equal to minus b by a into r plus 1. So put the value of this, and this here, and c by a here. So r into b square by a square r plus 1 whole square, and c by a. C. So r b square equal to ac into r plus 1 whole square. This is the condition which I got the relation here. But and hence find the condition so that the roots, two roots of this may be equal to each other. When the roots are equal, then r is to 1, actually 1 is to 1. So r by 1 equal to 1 by 1. So you can write here r equal to 2. So this is 3. Putting r equal to r equal to 1. Putting r equal to 1 to the condition 3, equation 3 or condition 3, maybe can say that. Okay, so this is equal to AC and 1 plus 1 whole square. So b square equal to 4AC. Okay, now we have followed the question number 25. See the question. In a quadratic equation of the form of x square plus mx plus n equal to 0, x square plus mx plus n equal to 0. Okay, the constant term is n, actually this is n, is misprinted 56 for 54. Actually misprinted is 56, this is wrong is 56 for 54. Misprinted 56 for 54. And roots are therefore obtained 7 and 8. Actually the wrong, this is the wrong root. And find the roots of the equation correctly printed. Okay. So now this is the wrong root. We have to find this is the wrong root. So 7 plus 8 we can write that is there m by 1. And but the solution of 7 into 8 is right here. That is this is wrong here actually, and this is n by 1. So n equal to 56 here. Okay, but which part is wrong? This is n is wrong here. So m is correct. So m is here minus 15. Okay, so therefore the correct equation is x square, and the value of m here is minus 15x. Actually now we have to change the value of n here. Misprinted 56 for 54. So misprint is 56 and right answer will be 54 here. So this is 54 equal to 0. Now solve this equation. So x square চুয়ান্ন, this is okay. Actually now we want to get here 15. So 6 or 9. So 9x and 6x and 54 equal to 0. And take common x minus 9 and 6. So then the roots are 6 and 9. Therefore the correct roots are 6 and 9. Okay. Now today this is the last question. We have I want to do this question here. So 628. This is a 28 and 3 by x plus 3 plus m, that is 5 by x plus 5 plus m equal to 1 here, are equal in magnitude but opposite in sign. So first we have to arrange this equation this is here 3x 15, 3m, 5x 15, 5m, and this into this are transferred to the right hand side. Okay, x square, okay, 5x, mx, 3x, 15, 3m, mx, 5m, m square. Now x square, we want to take a common x, all the x there, that is 5 plus 3 plus m minus 3 minus 5. Okay, and dot dot, not needed to write the other values there actually. And now x square plus x, and this 5 and 3 cancel, that is we have twice m, and this is equal to 0. Actually for this question we have given and the roots are equal in magnitude but opposite in sign according to the statement. According to the given statement, we can take the roots like alpha and minus alpha. So you know their addition will be 0 here. So okay, and that is here b by a, this is here 1. So therefore you can got the value m equal to 0 here. Okay, and for got value m is 0. Okay, all the viewers, see carefully. This is the solution of quadratic equation. I think you are all will be happy to see this video. Okay, see carefully. Okay, bye today.